Hi and welcome to this video which is part of the Transition Year Higher Level Maths Algebra Revision module. This Algebra Revision module has been put together to help you to revise the algebra topics from Junior Cert Higher Level, and this will in turn help you as you move into the Leaving Cert Higher Level Maths course. This video today will cover inequalities. So it's important to remember that inequalities are very similar to equations, except our equals has been replaced by our less than or equal to, greater than or equal to sign. It's important that you know the difference between these signs and you call them their correct names. And you'll notice that when we solve inequalities, we get a range of values rather than the singular value we get when we solve an equation. So we're going to focus on two different types of inequalities, linear inequalities and a compound linear inequality. So the linear inequalities are quite straightforward. A compound linear inequality is when we have more than one inequality in the sum. We're also going to do a little bit of revision on our numbers and how these numbers look on the number line. So as we discussed, an inequality is like an equation, but instead of an equal sign, it has one of those inequality signs. Sometimes students struggle to remember the difference between them and can sometimes get which side is bigger, but often lose sight of what that symbol means. So one way to remember it is that less than, it kind of looks like an L that's been tilted. The reason that I'm stressing that an inequality is like an equation is that in the majority of cases we're going to treat this inequality like an equation. There is only one time where the inequality does not act like an equation, and we can learn a very simple rule to get beyond that step. Before we start looking at some examples, let's go and do a very quick revision of our numbers. So if we want to do an inequality question, the three types of numbers that we see are natural numbers, which are denoted by an N, integers, which are denoted by a Z, and the real numbers, which are denoted by an R. Just to remind you, natural numbers are positive whole numbers. When we are graphing these on the number line, they appear as dots because we only want to include those particular whole numbers. Integers are positive and negative whole numbers. When we graph them on the inequality line, when we graph an inequality on the number line that are integers, again, like the natural numbers, we use dots because we only want those whole numbers to be included. When we deal with real numbers, we are dealing with all the numbers that are on the number line. When we show the real numbers on the number line in a solution, we use a solid line. So we can see here our number line, it has a red line going over it. It's important to remember that when we deal with real numbers, there's a slight difference to how we work at the end. If it's a less than symbol or a greater than symbol, we plot an open circle like this to tell the person who's reading our graph that all the values up to that point are included, but the value itself is not included. Then if we have a less than or equal to or a greater than or equal to, because that number is also included, we use a closed circle or a dot. So it's important to remember that these two symbols will only appear if we're dealing with real numbers. Real numbers on the graph or on the number line are graphed completely differently to our other two types of numbers, and it is important that you remember to include this open circle when we have no equal to sign and the closed circle when we do. Now let's look at a compound inequality example. This is an inequality that contains two inequality signs. So in this case, we have 10 is greater than or equal to minus 2x plus 4 is greater than 2. And they've also told us that x is a real number. So when we get the solution set, we are going to plot this. And when we plot this, we need to remember what we know about plotting real numbers, which is it looks like a solid line on our number line, and we have to be careful whether we have an open circle if we're including the number or a closed circle if we're not. There are two different methods for dealing with this. Some people do split this into two different inequalities. I'm going to work with the second method, which is the vertical balancing method. So if you learned the vertical balancing method but have moved beyond showing it, so we still talk about what we're doing but we may not be showing it vertically, I would advise you to, for this question, go back to showing it vertically. So I want to get an x on its own in the middle. So the first thing I'm going to do, I'm going to subtract a 4 from all sides. Now, because I have two inequality signs, I now have three different places that 4 has to be subtracted from. It disappears from here and I get 6 is greater than or equal to minus 2x is greater than minus 2. Now, I mentioned earlier that there is only one time where an inequality does not act like it equals, and this is the time when we have a negative in front of our variable, which in this case is our x. We want to effectively change our signs. But if I change my signs in an inequality, it causes a bit of a change in the sense that it will also change our signs. So what I would advise you to do is to learn this little mantra, which is change the signs, and then if I change the signs, I also change my inequality. And that is both inequalities, and both inequalities will switch. So let's see the change of sign. So 6 will go to minus 6, minus 2x will go to 2x, and minus 2 will go to 2. I then am going to change my inequalities. So I had it greater than or equal to, and that is going to change to the opposite, which is a less than or equal to. I then had a greater than symbol, which is going to change to a less than symbol. I know some people may have learned rules about when you're multiplying or dividing by a negative number, but often people get confused with those rules. So what I would suggest is this very simple little change the sign, change the inequality, and then treat any multiplication or division you need to do in the next step. So in order to get this x on its own, I'm going to divide each piece again by 2. Remember, vertical balancing. So I get a minus 3 is less than or equal to x is less than 2. And that gives me my solution set. Now we're going to graph this out on a number line, and just bear with me, I don't have a ruler. I can't use a ruler on this screen, but if you are drawing it, you are of course using a ruler. So let's go from 4, 3, 2, 1, 0, minus 1, minus 2, minus 3, and I'll put in a minus 4, and we'll end this. I'll try just tidy it up a little bit. Okay, so there's my number line. So what I'm going to do, just so we can see it, I'm going to go in with my yellow highlighter, and I'm going to look first at the two numbers. So it's between minus 3 and 2, but I have to be careful. The minus 3 is going to be included, okay? So that becomes a dot like this. That's because it's less than or equal to sign. The 2, on the other hand, is not, because it's just a less than sign. So instead of a dot, I'm going to do an open circle there. So I have my dot, at the 3, I have my open circle at the 2, and now I want to include all the values between them. So I'm using my highlighter to show that. And that is it graphed on my number line.